Hello, the Internet! Welcome to Open Source Directions, hosted by OpenTeams, the first business-to-business marketplace for open source services. Open Source Directions is the webinar that brings you all of the news about the future of your favorite open source projects. I'm Melissa. I'm a mathematician and software engineer based in Brazil, working with open source software and communities at Quantsite. And I'll be your host for Open Source Directions today. Co-hosting with me is...
Hi, I'm Tony Fast. I'm a developer advocate at Quantsite, and I'm also a community organizer outside of Atlanta, and I'm a huge Jupyter fan. Today, I'm really excited for us to have Nikita with us. Nikita, could you tell us a little bit about yourself, please?
Hi, my name is Nikita. I'm a CTO of Drylabs. It is a company based around the open source project called DryPython. And I also own a small company called We Make Services. Can you guess what we do? We make services, so. And by that, I mean that we do some consulting and some customer development. So that's why we need a lot of tooling to do it right. And today we're going to talk about it.
That's great. But before we get into the juicy details of DryPython, we would like to propose a PR of the week section. So do you have any pull requests that you found particularly interesting this week? So I'll start with mine. This is a pull request that we received at the NumPy tutorials repo, which is a recently created repository for educational content for NumPy. And this one in particular is really exciting. So it's a deep reinforcement learning script that trains an agent to play Pong from pixels. And it's really, really cool using NumPy and, like building everything from scratch. So it's kind of complicated, the code, but it's really interesting. So if you want, you can check it out, and it's super awesome. Tony, do you have anything?
Okay, I totally will.
Yeah, so I don't contribute as much code as I would like. So I watch PRs like soap operas and drama. And there is this one awesome PR where somebody had built these really great markdown tools for Jupyter Lab. And then a good friend of mine came in and made a huge PR. And the guy's like, well, this is a personal project. And he's like, this is a good project. So now he's trying to, now they're turning it into a more official thing. But it's really cool tooling and fun to watch the discussion happening.
So my pick for today is not really a pull request. It is just a commit because I really like to force push to master because I can. So it was a really lovely project. I started this weekend because, it is the perfect time to start a new project. And I really enjoyed working on it. I've spent the whole Saturday on it, and it was amazing. Like, I get so much, motivation from working on stuff like this. It is called MyPy extras. There are a couple of extra types you can use with MyPy. And this particular commit is about making a type called utter_of. It is a possibility to get an attribute of some object and to get its type. So it can be a generic type, it can be a fixed type. So probably anything except of union types for now, because it not works. Sorry. And that's it.
Really cool. I like those. So yeah, today we are here to talk about DryPython and Drylabs. So DryPython is a set of libraries for pluggable business logic components. It has about 1.4 thousand stars across repos on GitHub, so it's more than one repo. And it's got about 9,000 downloads a month across PyPI and Conda. So Nikita, can you explain to us what is Drylabs and what have you been working on?
Yeah, sure. I will start with DryPython, and then I will discuss Drylabs as well. DryPython is a set of libraries. And it is really important to highlight that it is a set of libraries, not just a single library. And what we're trying to build is to bring some new ideas from other languages into the Python itself and show how these ideas can benefit a regular Python developer. For now, we are focused on a library called returns. It is a set of primitives to write your business logic. It can really improve things like working with exceptions, because we have a special type called result. It is a better way to make exceptions a part of your contract. So it's not just like, it can possibly throw an exception. No, you are just really showing that this function is going to throw this type of exception, and you can probably highlight it everywhere you need. We also developed this new feature for Python, but not new in general, called high-kinded types. It is really impressive that MyPy allows that with little effort. So this feature allows you to express your ideas without actually showing how these ideas should be implemented. So for example, you can have a function that works with some client that goes into the HTTP and gets some page and then probably does some stuff around it. So like requests or HTTPX, something like this. And you can show that you allow this function to work with both async and sync clients without any code changes, without any type changes. It will just work with both of them, because both of them returns HTTP object, HTTP response. So that's fine, and we can work with this response later and do the correct thing with both cases. And things like this allows you to express ideas with types as values. So it can really increase the amount of possibilities you can encode in your types and in your business logic. So that's the first thing we are building right now. It's ready. You can try it. It's not perfect, but it is working and kind of production ready, I can say. So, and we're going to build some more stuff I'm going to highlight in the later sections, but for now, that's the main library we have. We also have some small libraries called classes. It is a single dispatch with types, so you are pretty sure what single dispatch will return to you. We can also use a library called lambdas. So this is something really important in Python, because Python has some issues with lambda functions. We all know that. And our project allows you to use just an underscore and operations on this underscore to show what do you really mean by this lambda. So you can skip a lot of syntax and just use it. It is also typed. It doesn't support all the things we want it to support, but it is better than nothing right now. So
very cool. Could you tell us a little bit about Drylabs before we move along also?
Yeah, sure. And the next question we had about these projects is how to make them sustainable, because I work on quite a lot of projects in the open source community, and I feel like I have some limit, because I cannot dedicate more time on working on more projects, and I have to cut my regular work to be able to work on these projects. And I like it. So I decided that I should probably make this sustainable so I can really dedicate my professional time on it, not just like random time in the evenings or in the weekends and so on. And we don't see any actual opportunities to do that, because it's not sustainable to receive donations, because we receive like $50 a month. So you just cannot live on this money. So we decided to go on another direction, So we decided to build high quality consulting services from builders of the technologies to the users of these technologies. So when we say like we can do consulting on, for example, dry Python, it means that me or some other core developer will come and show how you can use this library, how you can improve your skills about it, what can you read to understand the ideas behind it, and so on. And the same for other technologies we offer. Like we have our good friends from Django community. We have some other developers. We are mostly focused in Russian market, so we are mostly working with the Russian people right now. But we are working with OpenTeams to increase our coverage on international markets as well. So.
Well, that's very cool. So did anybody was anybody else besides you involved in starting this?
Yeah.
And is it filling any specific needs outside of making sure that you get fed?
Yeah, it is. There are 3 people behind Drylabs initially. My partner Valentin Dombrovsky, he is the organizer of Russian Python community called Moscow Python, and there was also a 3rd person. His name is Artyom Malyshev, but currently he is on kind of sabbatical. So currently there are 2 of us, but we were waiting for Artyom to return at some time. So maybe he will, maybe he will not. I don't know, but they're always open. So we have several other ideas about making this whole thing possible, because right now there are several problems nobody address, because for now, if you want to have a good consulting service, you don't know what to do, because you just cannot trust some people to come and give you some really important suggestion about your architecture, about your tools, about your internal team and how to structure it. That's a really important advice you can receive, and you should not just blindly follow anyone's advice. So you need some kind of a reputation to trust these people. And what can be better reputation than building some open source tools around it? So I guess that's a win-win situation for both open source developers who can monetize their projects by making their personal brand and then selling good quality consulting to clients that really need it. And they can have this multiplied effect. So they can teach, for example, 100 people, and they can receive a lot of money for this. It is not just regular coding service, because you cannot receive a lot of money for just writing code, because it is limited. If you want to be a 10x developer, you have to teach 10 developers to be a 1x developer. So that's how it works. And that's how good software engineers can make their open source work sustainable. And I really want a lot of people to consider this career in their future, probably their current future. So that's what we are building right now.
That's great. I loved your quote about the tenfold developer. That was awesome. Can you explain a bit about the history and of the name and the logo for DryPython? Is the logo a shell?
Yeah, the shell, it was originally created by Artyom Malyshev. And Artyom decided to make these libraries like connected together. So we created, he created this amazing branding, and you can tell by only looking at the README, at the logo, at the name of the library. It is returns, lambdas, mappings, classes. So you can even tell by name that it is somehow connected to DryPython. So we try to follow this scheme for other projects. And I guess he made a really great job on this. So I really enjoy our current brand and our style. So thanks a lot for building it.
Oh, the branding is striking. It looks really great, and the typography across the repos. Yeah, there's a lot of care in it. So I've never seen anything like these projects before. Are there alternative projects out here to what DryPython does?
Yeah, there are some of them, because we ported a lot of ideas from functional programming into Python. Obviously, we are not the first ones to try it, and there are a lot of awesome libraries. Some of them are quite new, some of them are quite old, so you can probably know libraries like funcpy and fn.py. These are popular libraries for functional programming, and I guess they're 6 or maybe 7 years old. But the main difference between our approach and their approach is that they are old libraries, and they were created before the type hints were a thing. So we leverage the whole typing ecosystem for our projects, and you can type check them with MyPy easily. So you just run MyPy, and you can get some sort of proof that your application will work. And for me personally, this works pretty great, because I write tests after the actual code. And firstly, I just test my code with MyPy. And if MyPy is happy, almost always my code will work correctly. So that's my personal experience with it. I cannot say that it will be the same for other people, because there are a lot of fields. You can use Python, and you can use different libraries. You can use different tooling. It might not be the same for other users, but for me, that's how it works, because I use Django. Django has static typing, and so it works perfectly. So
That's great. I just want to remind the audience that if you want to ask any questions, just go to our interface, and you can see the questions tab, and you can input your questions. We'll answer those at the end if we'll have time. So yeah, Nikita, what technology is DryPython built on? I think you discussed a bit before, but
we are using MyPy as our core dependency. It is not actually a dependency, because it's not required in the runtime, but there's like a dev time dependency. There is no such thing in Python, so we're just calling it a dependency, but it is not actually. And type hints, because we really use a lot of type hints in MyPy. Some people who look at the code inside the DryPython think that their code, the end code, will look the same. No, that's not true. Their code will be still simple and pythonic. The ugly parts are hidden inside this library, and you don't have to worry about it. Like, just use your beautiful decorators, beautiful functions, and stuff like this. We will do the rest for you. And right now, when the foundation is ready, I can call it ready, because for now we support all the things we want to support. We have all the containers, as we call them. They're not really containers, they're monads. So that's a bit of the mystery. We don't call them monads in public. We call them containers. We have all the containers we need. We have the high kind of types to allow users to write their own containers. And we also created this new thing to prove that your implementation is correct. It is called monad laws as values. Sorry, this is how it's called. It's not container laws, it's monad laws. Sorry. What we do is we encode actual laws of how things should work inside the implementation. And then you can call just one function, and our tooling will check that all these laws are correct, that you will actually have a working monad implementation, or functor implementation, or applicative, anything you need. And we do that by leveraging hypothesis and property-based testing. So we have interfaces, like, for example, we have a mappable interface, which is really a functor. but we call it mappable because it has the only method called map. And it has two laws of how things should be. And every class that inherits from mappable automatically inherits all its laws. So when you write check all laws my type that inherits from functor, you will have this law checked for you. You don't need to do anything. Just write your code and it'll be working. So that's the foundation we need. And after that, we can create new libraries based on it. For example, for validation, for REST frameworks, we want to build a really easy and really reliable REST framework. We have some really cool ideas. For me, I think that they're cool. Other people might not agree with me, but I can shed some light on it. For example, a lot of people right now tend to use data classes to model their REST APIs, and that's a cool thing. It is really easier than to use, for example, Django REST framework, which has a lot of serializers, a lot of fields, and you have to connect all the things together, and it can be a little too much for a simple REST framework. But I wonder why not people using dicts, because JSON is a dict. Why do you need a class to work with a dict? You can have type dict, because we already have this. We already have type dicts, and you can probably use type dict. Why do you need any other class to wrap it? And this can be amazing for two reasons. The first one is performance. You don't need to actually create new objects. You can have just dict. So you receive the dict and you work with it. No extra objects created. And the second idea that working with dicts is easier than working with classes, because you don't need to serialize it and deserialize it. For example, if you need to save this dict, you can directly access its values and save them in some database and models or whatever. But you don't need to serialize and deserialize that. And if you need to deserialize a model, for example, you have some Django model and you want to convert it to a JSON, you can use a tool like classes. It will have a function called toJSON, and this function will single dispatch your type, and it will return a dict from it. No magic, no performance hits, because it is as simple as calling a function and returning a dict. So I don't see any problems with that, and that's the foundation we're building our REST framework. And you can probably see that I haven't mentioned Django or some other technologies here in the context of REST framework, because actually this REST framework can be applied to any technology. You can use the same REST declaration with async IO and IO HTTP or fast API, fast API. I'm not sure how it's called in English. I've never heard how people pronounce it in English. You can use the same API with Django, because we have high-candidate types and we can encode ideas and then just supply a different behavior that will match this type. So you can create a package with the REST API. It will be fully covered by Swagger. It will fully covered by types, and you can use it everywhere. So no need to change your code, no need to change your application logic, anything. Just use it. And that's the foundation we are going to. That's not the foundation. That's the next features we're going to build with our current foundation. So.
Very cool. Well, I'm going to be on the lookout to see if using container instead of monad actually makes functional programming cool. So I'm curious. You're one of the maintainers pushing these container ideas. Are there any other folks that maintain these projects?
Yeah, we also have Pablo Aguilar from Brazil. He's our contributor and core developer. He's also a part of Drylabs, because He does some amazing webinars for English-speaking people. We also have two other people who are not active right now, but they were really helpful in the past, and I hope they will be working on our projects later on. So Dmitry and Artem. So yeah.
Really nice. And I'm happy to find like a fellow Brazilian and the maintainers of the project. So what communities are your users and contributors from?
We are based in Russia, and our core team is mostly Russian for obvious reasons, because they're our friends and colleagues and local people. So, but right now we are trying to expand to other countries to find some other users and code developers in other countries, so they can share our ideas with their colleagues and their friends. So that's how ideas conquer the world. So
well, clearly the members of the DryPython community are involved in the Russian community. Are there any diversity and inclusion efforts that you all participate in to enlarge your communities and enhance them?
Yeah, I try to work on this really hard, because, you know, there is one superstition about open source, that a lot of developers believe or think that they're not good enough to contribute to open source. And this thing's killing me, because I know a lot of great developers who are so talented and gifted, but for some reason they are not believing in themselves, and they are scared of contributing. And I work with a lot of students, and I encourage them to contribute to open source. I help them to contribute. I review their pull requests before they submit them. I do a lot of things to encourage people to contribute, because as open source developer, I understand that people are the most valuable asset in our work, because they literally build this stuff with their heads and hands. So we really need a lot of different developers to contribute to open source, and I try as hard as I can to encourage or to enlighten people to believe in themselves, so they can understand that contributing to open source is not scary. It is a pleasure, and it is a really warming experience that you feel like, oh, I did something great. And that's the thing I try to encourage.
That's really great. And I'm happy to see that your community is like healthy and moving forward in that direction. So now we're going to move into the project demo, and we'll get to see some of the features of DryPython, how it works, or anything else Nikita wants to discuss. So Nikita, I don't know if you're going to share your screen, want to share something. While you're getting set up, we would like to take this opportunity to thank our sponsor, Quantsite, for sponsoring this episode of Open Source Directions. Quantsite, creating value from data. So whenever you're ready, just go ahead.
Yeah, I'm ready. So I will cover several things in this tutorial. We will start with our README, because that's what you should start from. And we will cover our main project right now. It's called Returns. There are several things I want to share from this README. Can you see it well? Is it working?
It looks great, and so does the branding.
Okay, thanks. We have a docs file. Sorry for that, you haven't seen it. The first thing I want to highlight is that we have a Telegram chat you can join if you're interested in using or contributing to our project. If you feel like you want to contribute to open source, but you don't know what to contribute to, please feel free to reach me in this chat, and I will help you. And the second thing I want to highlight is the set of features we have here, because that's a really short and really explanatory set of features we have. So if you read them, you will understand half of DryPython for now. So we will just scroll down and see some more contents about it. And the first thing I want to show is our maybe container. We don't call them monads for a reason, because people are scared of this word. For some reason, functional programming looks to be hard, but it's not. And to make it easier for newcomers, we call these things different names, so they won't be scared, and they will just read through the docs we have, and they will understand what we are talking about. So you can probably see this pattern in your code a lot, because Python has none as a value, and a lot of functions can return none in some cases, which probably indicates that there is no value to return, or that there is some error. So you can just return none from almost any function. And if you do that, you will have this pattern. So you have to check if some value is not none, and then do your thing. It's probably okay in some cases, but in some cases it will end up in something like this. It is a ladder of if is not none, if is not none expressions. So that's not a cool thing. And it can be easily changed into this functional approach. It is absolutely the same, but it is written in a flat style, and it is using our container called maybe. It is pretty much the same as optional, but with extra methods, like bind optional. Bind optional works by executing this lambda function whenever the value is not none. So if the value is none, it will not be called. If the value is not none, it is going to call this lambda function and return the value wrapped in the maybe monad again. So that's how it works. And that's very easy to understand, and that's why it is the first example in our README file. And the next, we're going to move to a container called requires context. And it really helps to build a scalable architecture, because it allows to call functions with several parameters which are missing. So, for example, you have this Django application. You have your view, and you have your business logic. And you have a function called calculate points. It receives the strings and returns int. So you receive some word, you count letters in it that are guessed, and the guessed letter is something that is not dot. And later you count points for this word, for example. So it's pretty easy. The problem comes when you want to change, for example, this value 5. What you can do is you can add extra parameters to each call. For example, you can have word, str, and then threshold int. But you will have to do it for every function in the chain. That's not a good idea, because it will spoil your application really fast. But on the other hand, you can use our container called requires context. It is a reader monad from functional programming. And what it does, it allows to call your functions with not all the parameters in place. So we can refactor our view and our logic to look like this. For example, you start with calling calculate points with the word provided by user, and then as a second parameter you pass your settings. So what happens here is that right now your award points for letters returns not just a value, but a value wrapped in the requires context or container. And it has an extra call method that accepts the values that you need to pass on the second iteration. So in our example, the settings. So that's how you can decouple your settings from your logic, and that's how you can decouple your logic from your Django or from your other framework of the choice. So next, we are moving to the result container. A result container is something that is probably the most contradictional in the Python community, because Python developers are used to raising exceptions, and result returns them instead. So we can have a function that, for example, makes a request to some API, then it raises an exception if this request failed, and then it returns a JSON response from it. But inside, every call in this function can possibly raise an exception. And we can understand that raise for status probably can raise it, but other functions, it is not clear that they can raise anything, or it is not written anywhere. So it's hard to remember that some functions do raise exceptions. And what you can do is you can refactor your application to actually work and look like so. So what happens here is that our make request function is marked as safe, so it will never raise any exceptions. It will return them as values. And the same for our parse JSON. And you can convert your business logic to this declarative approach of composing different functions. So your whole application is going to look like so. Flow, the first parameter is your data, and then only functions. So if you have like 5 steps, you can have 5 steps of functions, and that's fine. And in the end, it will return result. And here's your successful value, and here's your failed value. So this allows you to express what types we will be successful and what types will be considered as failed. So you will never forget that you have to work with exceptions, and that's why it is a great thing. But for some reason, Python developers don't like it, and I try to show different cases in which this technique is really useful, and it will protect your code from unexpected exceptions in different places. How do you like it?
It's wonderful. I wouldn't have thought to come up with some of these solutions.
Do you know any other functional languages other than Python?
No, but the one tool that I'm most experienced with is tools and Dask. So like functional methods, but using Pythonic idioms. Okay, so let's move further. The next container is called I/O. By I/O, we mean that this function is not pure. You can clearly see that, for example, get random number is not pure, because a pure function is some function that will return the same result for the same inputs. But get random number will always return you a different number. So that's the whole point of this function. But sometimes you have to think about what functions are pure and what functions are impure to create a beautiful architecture and to make your application layered. Because you want some impure stuff to be on the very, very last layer, so you can easily switch it to something else with mocks or composition in your tests or in your docs, something like this. And this
monad allows you to actually express this idea. So if you have something wrapped in IO, you will not be able to unwrap it. If you have some value marked with IO, it is forever. So this allows you to stick this IO marker to your values. And if you have at least one IO value, it will not be possible to say that the whole result is pure. So the whole result will be impure. And this really helps you to understand the data flow in application. Because for now, if you see that, for example, some function returns 4 as a result, is it pure value? It just returns 4? Or is it impure because it cures the database and shows how much users do you have, for example? It's not clear from the function itself, and you cannot tell is it safe to use this function, or for example, it can fail. That's really important in the big applications. So we use IO to mark functions that are impure. And this helps you by creating a layered architecture, and it really helps you separating pure parts of your code from impure parts of your code. And we also have IO result. It is something that is impure and can fail. For example, all database connections, all HTTP connections are impure and can fail. So it is probably a good idea to decorate them with IO result as a container. And we also have a future container. It is probably the same as IO, but for async code. The problem with async code is that you have to add extra async and await keywords to your business logic. It is not really a big problem for people who is writing their applications, for example, in async IO, and they just know that they will use async IO, and that's fine. But it is a big problem for library authors because they don't know how their code is going to be used, and they have to create a lot of compatibility layers to make this whole thing possible. But with our approach, for example, with future container, you can abstract away how your IO loop works. It can be synchronous with IO, or it can be asynchronous with future. So you can compose things in IO independent manner because you are going to use map, bind, and other methods from functional programming, and they will hide away the exact method of composition. So, for example, future map will always produce a future, but IO map will always produce an IO. And for functional programming, it is not really important what type do you have. It can be both future or IO. It will have the same properties, so it is fine. And that's probably it. I've covered the whole README. We also have some more information if you're interested. There are at least 5 articles you can read. And we also have a great docs, I believe. There are a lot of examples, a lot of questions that are answered, a lot of links for other projects, books, tutorials, everything we can find. So
that was very cool. I like functional programming in Python because it's so impure and has all the side effects. It looks like, so we've got a few more articles that you shared, some on higher kind of types and some on the interfaces project. So we'll share those in the chat. And I think, Melissa, now it's a good time to get to the roadmap and see where the project's going.
Yeah, so can you talk to us a bit about like where is the project going, recent changes and things that you have planned for the future? And I certainly would like to note also that your README looks really great, and you know, like the examples and taking the user from one step to another, that looks awesome. Like, what
Thanks.
are your plans regarding the rest of the project? Where are you going, and things that you want to do with the project moving forward?
We had the big release like 2 weeks ago. It was this release with high kind of types, and we had to break a lot of things because I made a lot of mistakes in initial methods and initial interfaces, because when you don't have a type checker to assist you, and you don't have laws to test your implementation, you will have problems. So sorry, users of our previous version, you will have to change a lot of things, but now these things are correct. It is proven that they are correct. And we also shipped a lot of new features. For example, we shipped a very user-friendly method of working with iterables. It is called fold, coming from functional programming. It is called foldable. It is an interface that can really assist you with working with lists, for example, of results. Because it's not really easy to work with a list of results the same way you can work with lists of values, because results can be failed or they can be successful. And you need some extra tooling to do that. We also focused on the async part of our application for now. It's not perfect because I'm not a big async user, so I'm not quite sure what things we need there, because I'm not using it myself, and I need some advice on that from more experienced async users. And right now, there are some really hard tasks to do. For example, it is really problematic in async IO to work with supervised trees or stuff like this, because if one coroutine fails, you need to cancel all other coroutines. It's not really easy to do that in async IO, for example. And we are based on async IO, so it's really harder to do the same thing with future than with pure async IO, obviously. So we need extra tooling for async IO to make these things easier than it is without it. So that's why people are going to use it. And there are a lot of things we need to improve in the standard library, because, for example, there are a lot of awesome functions in Python. For example, any. It is really easy to query some iterables. If any of this value is like equals to 3, then do this. And for now, it's not the same with functional primitives, because we also need to unwrap this value, and this can be synchronous value, asynchronous value, dependent on the context value, all other things. So we need to provide some better primitives to work with Python, and how people can interact with the known standard library with new values. So, and we're also going to build a new project called Mappers. It is going to be like data classes, but for dicts. Because right now, type dicts do not support, for example, default values. And that's a big problem for me, because I'm going to use type dicts a lot. So we need some other abstractions and some other tooling on that.
So it sounds like the ecosystem around DryPython is growing a little bit more. You got the core internals going. Where do you see the ecosystem going, and yeah, how do we think about that?
I can say that there are 3 main projects for us right now. It is called Mappers. It is going to be on mappings. I get mappings. Sorry, I don't remember the name of my project, so what can you expect from a guy like me? So,
it ends with an S, right?
yeah. This is going to be this attrs or data classes, but for dicts. Then we're going to build a validation library, because right now all other validation libraries are not fulfilling all the requirements we have for them. For example, a lot of validation libraries are mixing up the schema validation and the type validation. For example, you have this user field, and it can be both email or user object. And at the first step, you need to validate that this field is there. It doesn't matter what type it is, because you can cast these types from one to another. You can query username, you can query a user from its email, and that's okay. But that's the first step. At first, you need to check that the schema is correct. On the second time, you need to check that your types are correct. And then you have to check that your business rules are correct. For example, you can send an integer, but this integer represents an ID in your application, and that ID does not exist in your database. That's the whole new level of the validation. And you can choose how you can validate these values. For example, you can combine all 3 layers into one response if you want to cover everything. Or, for example, in other cases, you need to check layer by layer. For example, you need to check that all values are there, then you need to check that all types are correct, then you need to check that all business rules are correct. It really depends on your use case. And for now, I don't know a single library that allows that. So that's why we need our own, and it is going to be a valuable part of the ecosystem. And in our main project for now, that will represent REST's framework.
Wow, that all sounds really cool. And you can see that the project is moving forward fast and you're doing a bunch of stuff. So congratulations. I think it's a really nice project. So unfortunately, we're getting close to the end of the show, and I don't think we'll have time for questions, but maybe people can reach out in the repos or in the Telegram group that you mentioned before and ask questions and maybe communicate with you. So I guess we'll just move to our world famous rant and rave section, where we each get 15 seconds to rant or rave about whatever topic we want. Nikita, do you want to start?
Yeah, I'm going to rant about MyPy internals. MyPy is great. I use it a lot, but every time I try to contribute some big portions of code changes to MyPy, I fail every time, because it is really complex, it is really big, and it is really hard to understand. So that's my rant.
Tony?
Yeah, I wanted to go back to something Nikita talked about earlier, and you know, imposter syndrome is not something you have to deal with. Put yourself around people who bolster your confidence, and you know, make the best of next year. You're good and valuable at coding, whoever you are.
That's an awesome message.
I double that.
And I'll complete. So my rave is about Python Brazil, where this is our local PyCon conference, and we discussed about all these topics that you're mentioning, like beginners, how to be a community that is beginner friendly and that values every contribution, no matter the experience, no matter where you come from. So I'm pretty happy to be a part of that, and I'm raving about it. All right, folks, that's all the time we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at OpenTeams Inc. and at Quantsite AI. Nikita, where can people find you and DryPython?
On GitHub. You can follow me on GitHub, or you can watch some repositories you are interested in, and you can join our Telegram group, as it was already said. So please feel free.
I would assume the Telegram group, you have that information on your GitHub, right?
Yeah, in the README of each repository. So
it was a good README, remember? It's in there.
Yeah, it was awesome. So if you liked what you saw today, please go to our YouTube channel and like and subscribe to see more of this content. We look forward to you joining us next episode for a look inside X-Array Spatial. Thanks, everybody.
See you. Thank you. Bye.
Thank you, Nikita.